It's muted.
All right.
Okay, so I'm going to turn my speaker down.
Oh, yeah, turn it off.
If you can't actually. I think it's muted. Okay, so come on. All right,
Sorry for the interruption.
What'd you do? Okay. And my speaker's not muted because I can hear it. It's taking over control of my machine. Oh yeah, nothing's working. Okay.
Uh-oh. Technical difficulties. Now the voice is
Yeah.
Yeah, see?
Progress.
Now you get audio.
There we go. It's,
Yeah, yeah,
now it's working.
Okay.
Okay. I don't know what the deal was. It took away control there. All right, so the things that we're going to be going over, an overview of performance monitoring, error logs. You may ask why error logs. There we go. Now it's TempDB, file and wait stats, and then the last thing has to be who is active. How many people use that today? Okay, pretty much everybody should be raising their hand on that one, and you'll see why when we get to that. And then hopefully we'll have some time for questions. Yeah, so overview of performance monitoring. Performance monitoring with SQL Server is a big area. And SQL Server itself is a big product. It used to be, back when I was first in SQL Server and I first became an MVP, I felt like I had a pretty good handle on the overall SQL Server product. But nowadays that's impossible. Somebody tells you that they're an expert in all of SQL Server, it's not going to happen. There's just too many pieces of SQL Server for that to happen. BI, I don't even try to go there. I mean, it's not that I don't want to. Well, I don't, but but there's just too much in that. Even I used to be pretty good with DTS, but then when SSIS came along, I just didn't have time to to follow that. So I concentrate on mainly the core engine, the SQL Server, relational engine, and I specialize in the things that go along with that. And there's still a lot of that. So performance monitoring is a big aspect, but the key is to try and get a handle on that and just really look through all that stuff to see what's really going on. I don't know what just happened there. But one thing is when you go to get data, when you go to capture data, you got to remember too much data can definitely be overwhelming. And that's one of the biggest mistakes that I see people doing, starting out trying to get a handle on performance tuning or performance monitoring in SQL Server. They go out and they set up perfmon counters and they buy third-party tools and they do this and they do that and they capture all this data. And then what happens is you got all this data, and then you either don't have the time to weed through it or you don't have a clue where to start to weed through that. So too much data is definitely can definitely be a big problem. And the majority of the people that I see, they collect too much data, they just give up. They eventually just look at it and say, this is just too much for me. I'm going to go back to doing what I was doing before, and then then you're kind of stuck and you're back where you were again or were before. But on the other hand, not enough data can lead to wrong assumptions. If you're only collecting a small piece of the puzzle and you act on that, you could be going off in the wrong direction with your troubleshooting. For instance, a common thing that people will do is they'll start looking at durations of their store procedures or their query calls. They'll run a trace or something, and then they'll go off and they'll say, okay, well, this store procedure's taken 10 seconds. I'm going to go off and start troubleshooting that. Well, that 10 seconds could be because you're being blocked by some other process, and that store procedure, had it not been blocked, would run in 200 milliseconds. So if you don't take into account the big picture and look at all the aspects of it, you'd be spending time doing things that you don't need to be doing or going down the wrong path. When we get to the wait stats, there's another prime way that you can kind of just get misled if you don't look at the big picture, and we'll talk about that. So you got to find a balance between the two, too much or too little data. Well, the thing is, start out something that you can manage. And initially I say go on the light side. Start collecting the data and start analyzing and looking. And eventually you're going to find that there's something in there that you're missing. It might be okay to start with, and then some other thing will come up and you say, oh, well, I don't have any data. This happened, but I don't have any data to correlate that. So you add some counters in there. It's better to start small and work your way up. It's going to take time, and it's going to take experience to really find out what it is that you need and how to go about doing it. And when it comes to SQL Server, actually I think the last bullet on there is experience is the best teacher when it comes to performance monitoring and performance tuning. You're just not going to pick up a book, read it once, and then become an expert on SQL Server, and especially when it comes to performance in SQL Server. It's going to take time. You're going to make some mistakes. Everybody does, and everybody will. Just learn from your mistakes and then build off of that. So another aspect that you have to be a little bit careful on is how you collect the data, because if you collect it the wrong way, you can do more harm to your system than good. And a good example of that would be trace. How many people use Profiler today? Well, Profiler is a great tool, but Profiler can be your worst enemy on that. If you just set up Profiler, if you're having a problem, somebody comes to you and says performance is through the floor, what do? I see that people pull out Profiler and they start tracing, and they'll turn on all kinds of events. They'll do down to the statement level event. And every event that you're tracing, every extra event that you're tracing, every column, every bit of data that you're collecting that you add onto there adds more overhead to SQL Server. I did a test for a magazine article many years ago running trace, and then I had a load tool against it, and I graphed how much trace would impact your throughput. And it was amazing, especially when you get down to the statement level. I was running a test that was doing about 10,000 transactions a second, and I turned on Profiler, running a statement level trace, and it dropped it down to like 1,000 transactions per second. I mean, that cut off 9,000 transactions per second just by turning on Profiler on there. So you have to be a little bit careful about what it is that you do. But, again, the good news is experience won't be your best teacher. I was doing a thing overseas in South Korea for a major company. They had at the time it was a big system. It was one of the big 64-bit systems, had 32 real processors way back when that was a big thing. And I made the mistake of running a trace. I wasn't using Profiler, I was running trace, but I commented out the wrong line. And I did have the statement level on. And I started that trace, and as soon as I hit the button to start it, I realized I had commented out the wrong line. And so I started it, and I stopped it, literally that fast. And in that time to do that, the system, this was a major company, and they had all these dashboards set up, and they were showing all kinds of activity, connections, this and that, whatever, and alarms and whistles, and you name it, started going off. I didn't have that on, no exaggeration, for more than 2 seconds, and I took that server down to its knees on there. I won't do that again.
Yeah.
But people, you're going to make mistakes. Obviously, it's not like you just want to go in and make mistakes and let that be your teaching tool. But you are going to make mistakes with performance monitoring. Learn from it. Don't let it get you down. Don't let it discourage you from going further with that. So, as a big picture, try not to get overwhelmed by it. Try to focus on what it is that you want to do. What are your goals? How are you going to collect this data? And then, more importantly, how are you going to analyze it? Because, again, a lot of people will go and collect the data without giving thought to what am I going to do with the data once I get it on there. That brings to this: first, determine what your goals are. When you're doing performance monitoring, you generally have a couple different types of goals. One of them could be a baseline, or should be a baseline. Baselines are extremely important. However, for the most part, baselines are very hard to do. Take a lot of time, traditionally, take a lot of time to do, but they're very important. I'll come back to that in a minute. And then you have like your daily monitoring, and then you have your troubleshooting. So the daily monitoring would be once you've gotten a handle on what's going on, you don't need to monitor all kinds of things. You just need to know, how busy are my CPUs, how many transactions, what's my block, is anyone being blocked, those kind of things, and normal stuff, just to make sure that you're running good. And then if you have a problem where you're actually troubleshooting, you're probably going to go in and start collecting more data. If you're using perf non-counters or traits or something, you'll probably open those up and collect more data to do the troubleshooting. But make sure you have different goals for that. You don't try to do it all in one on there. Now, coming back to the baseline, baselines are extremely important because if you don't have something to compare your results to, you could miss a lot of things. If I'm collecting, let's say, execution times of my stored procedures, and I've got a whole bunch of them, and they're averaging 200 milliseconds a piece to capture. Well, if they're slowly starting to creep up with the time, and they go, tomorrow it's 201 milliseconds, and the next day it's 202 or whatever, and goes on like that. If you're just looking at it like once a week, it might seem fine. If it's 200 now and it's 205 next week, that's probably fine. As users aren't complaining, you're probably good. But if you had a baseline that said a week ago they were taking 200 milliseconds and now they're 205, and then 2 weeks from then they're 210, you can see a trend and see that they're starting to go south. If you don't have that baseline, it's very hard to get that view into the system because you want to be proactive, not reactive. You don't want to wait until it actually becomes a problem. You want to try and catch it before it gets there. Now, the big problem with that is that baselines are difficult. Not that I'm trying to plug a vendor, But SQL Sentry, most of you guys are probably familiar with SQL Sentry. They were one of the logos up on the screen there.
They're a sponsor.
Yeah. And they're actually not far from here. They're in Charlotte. I don't know, maybe it's that way. But
Yeah, that's where last month's speaker comes from.
Yeah.
SQL Sentry.
Right. But they now have, in their performance toolkit, they have the ability to take baselines, and they have the ability to compare the different parts of the metrics that they're gathering against those baselines, and give you very, very good insight into what's going on in that. And actually, I think I might have it on one of these slides here. Yeah, this one here. One of the things that you have to decide, are you going to roll your own, or are you going to buy a third-party tool? There's no right or wrong answer to that. But I do have to say from experience that if you have the money to purchase a third-party tool, I would suggest that you do it. And when I say that you have the money, it's not just, you can't just look at it as, okay, well, this is going to cost me whatever the cost. I'm just going to say $1,000. It may be cheaper, maybe more, depending on how many systems you need to monitor. But you can't just look at it as that price right off the bat. You have to look at how much time it's going to save you, how much aggravation it's going to save. Your boss may not care how much aggravation it's going to serve you or save you, but he will care how much time that it might free up that you can be doing other things on there. And I have to tell you from experience that the third-party tools can be a huge time saver. If you had to try and write even a fraction of what most of the third-party tools have, you would spend all your time just trying to write the tool and not getting anything done on there. Baseline, right there. I know companies that spent about 5 or 6 man-months with a team of people just trying to get a solid baseline on their system that they could have done in days, setting everything up from start to finish if they had the third-party tool at a fraction of the cost. So don't just look at the overall sticker price. Look at the big picture when it comes to that. Sometimes writing your own is just the way to go. If you have something very specific, you go there. I use, most of the time when I'm going into a client, I will use my own tools because typically they don't have those tools, and I need to be in and out of there in a day. But I do use, in one of my clients, I use SQL Sentry to get the overall day-to-day stuff, especially since we've got an enterprise. So it's up to you, but no matter what you do, that last bullet on there is extremely important. You have to set aside the time to implement it, whether it's your own tools or whether it's the third-party tool. If you don't plan ahead of time, X many days, X many hours per day, X many days per week, or whatever, to get situated, you're never going to get to where you need to be. No matter what it is, you need to take the time to implement it and implement it properly. Because even after it's implemented, you still have to take the time to look at the results on there. And if you don't plan for that, and you say, well, I'll do it when I get to it, it's not going to happen. Anybody disagree with that? Again, I know that from experience. Error logs. Okay, so what do error logs have to do with performance monitoring? Anybody answer that?
There's performance errors in the logs.
Exactly. The error logs have information that may relate to potential performance issues on your server. There's a number of things in there. Can anyone mention something we've probably all seen? It's probably kind of common. Yeah, I/O taking longer than 15 seconds. Anybody seen that in their error log? Well, you have to look in the error log first to see it. But if you see that message, that's not a message to be ignored. If it says I/O is taking longer than 15 seconds, an I/O should take milliseconds, several milliseconds, not 15 seconds. And the threshold, just a note on that, the threshold to be reported in the error log is exactly 15 seconds. So if it was waiting for 14.999 seconds, it's not going to be reported. So for every error you see in the log, there could be hundreds or thousands more that were between the normal range and the 15 seconds that are not reported. So it's actually probably much worse than what you think it is just by looking at the logs on there. But the good news is the error logs spell it out for you. Right there, they tell you you're waiting, and it even tells you what you're waiting on. It tells you the LUN, the path, whatever the file that you're waiting on. But if you don't look in the error logs, you won't know that. There's other things in there, like when you start up SQL Server. As a matter of fact, if we look at the error logs, and there's nothing special about this machine. It's a pretty simple machine, and hopefully you guys can read this. But if you go down to the bottom where it first starts up, and you still might not even be able to see it, but it tells you certain information as it's starting up. It'll tell you, the license, the version, things like that, the edition stuff. But there'll be a point where it will say, starting at a normal priority, if you had done something wrong, how many processors, how many sockets, things like that. If you think you've got 32, but it comes up and says it only sees 16, that's probably a red flag. This right here, using dynamic lock allocation, if you're using lock pages in memory or not using lock pages in memory, if you think you're using lock pages in memory, but it's not actually using lock pages in memory, it'll tell you right there in the logs. So there's a lot of good information in the logs that you should look at on a regular basis. Now, this kind of stuff, obviously, you don't need to look at that every day. But things like the I/O taking longer than 15 seconds or other types of errors, it's nice to know when those things are happening. I've got some demos that I'll make sure that Brett makes available so you guys can have them. But I'm not going to go too much into it here. But here's a store procedure. I think I've got 3 of them on here that will go through the error logs, and it'll find things. And the I/O taking greater than 15 seconds, I have a client that has about 100 machines that we have to monitor, and they're all connected to SANs, and the SANs are the worst things on the planet. They are old, they're overloaded, they are in very poor shape. So I will literally get, between the 100 servers, I will get hundreds of thousands or millions of these I/O messages every day across all the servers. Well, I wrote a store procedure that will aggregate it up. If I run this, it will go through, and I don't have any on my machine here. This is all SSD, so I'm not going to get that here. But it'll aggregate it out. It'll give me an overall picture by server, what's there. It'll break it down by LUN, and it'll break it down by day, and I can keep a history on that. So it's nice, again, to keep a history on that. If you've got that problem, start keeping track of it, and then as you make changes, look and see, am I getting better or am I getting worse on that? As you make changes, you got to know whether your changes are doing good or not, and this is one way to tell. The store procedure, it's pretty straightforward, but basically it'll loop through, it'll look at your logs, and it'll, your SQL Server error logs, it'll loop through them, and it'll pull out, in this case I'm looking for a specific message like this here. But you can make that whatever you want. You can look for other types of errors and capture this stuff, and you don't have to do anything other than run the store procedure. You can automate it and have it send you an email with that stuff. Anybody look at their error logs each day? One.
Yes, I do.
All right. So that's what error logs have to do with performance monitoring. There's a lot of good information in there. Just look at it. It's not the kind of thing that you have to spend hours doing, but get a handle on it and get to know your system a little better. All right, TempDB. And by the way, I don't have what is we got to what 8:25 or so.
Yeah.
Okay. So
You got plenty of time.
All right, TempDB. Does anybody use TempDB? All right, so speaking of use of TempDB, there's a lot of things that use TempDB. I find that a lot of people don't really understand what uses TempDB and why it's so critical. I've got a couple slides here. Don't worry about reading each of these specific things. It's really just to show that there's a lot of things that use it. Intermediate result sets, your temporary tables, obviously. Anytime you use text or image or blob type data, TempDB is used. Service broker is used behind the scenes in SQL Server for almost everything. Uses TempDB. So, do you know that triggers use TempDB? It used to be the triggers when you looked at your inserted and deleted tables, those virtual tables, you used to actually pull that information out of the transaction log. And now they store that information in TempDB as it's happening, and then you access it through TempDB. So it's actually makes your it's more performant because the log file doesn't have to be read each time, but it puts more into TempDB. Every time they add something to SQL Server, it usually has an impact on TempDB. MARS, actually I think it's on the next one. The MARS, multiple active result sets, TempDB, snapshot isolation. When using any of the snapshot isolations, that information is stored in TempDB, on and on and on and on. Almost everything that happens in SQL Server in one way or another utilizes TempDB. There's only one TempDB for your entire instance, and if everything uses it, what does that mean?
Better be optimized.
It better be optimized, exactly. It better be running well, or you have the potential to impact almost everything that happens in your SQL Server instance just by not having a good handle on TempDB. The same client that I was talking about before with really bad performance on the SANs, when I took over, the TempDB on some of the bigger servers was averaging anywhere from 800 to 1400 milliseconds average latency on reads and writes in TempDB. So that means, on average, any read or write was taking over a second to happen. And if you were to look at your counters, like your transactions per second counters by database, you will probably find that TempDB has more transactions than all your other databases combined on there. Not saying everybody's going to be that way, but on average, more than not, that will be the case. And TempDB is often one of the things that's thought about afterwards. They think about where we're going to place our data files, where we're going to place our log files, but they're talking about their user databases, and TempDB seems to be an afterthought on that. It shouldn't be. It should be in your mind right up front. And there's a lot of things that you need to you'll need to keep an eye on in TempDB to make sure that it's not impacting everything else in there, because the example I used before where we had a store procedures, and let's say store procedures taking 10 seconds to execute. Well, there could be a lot of things for that. It could be blocking. It's a good thing. But if you have some kind of repetitive operation going on in there and it's utilizing TempDB, and TempDB is taking 500 milliseconds to do those writes, it doesn't take too many of those iterations before that time rolls up. And that's multiplied by all the users, because all the users are using TempDB. Well, any concurrent users are using them at the same time on there. So it's important to keep an eye on TempDB in a number of different categories. We have space issues. Anybody ever run out of space in TempDB? It's one of the things that you don't want to do. You run out of space in a user database, what happens? Users can't do any more writes on that. Okay, it's not what you want to happen, but it's not really the end of the world, because the users in the other databases, they can still go do their thing. If you run out of space in TempDB, you could blow your whole instance on that, and then you affect everybody. So monitoring space in TempDB, I would say, is probably a higher priority than monitoring the space in the database. Not to say that you can just ignore them, but TempDB has a bigger impact on there. I/O issues. TempDB has data files and log files just like user databases. It just gets used a lot. So your normal I/O issues come into play with TempDB, maybe even exaggerated. And we're going to look at some examples of some of those things in a little bit. DML and DDL contention. What do I mean by that? When you go to create objects in TempDB, and that could be from a number of different reasons. But let's just take the most common example, which would be a behind-the-scenes temp table, or what's commonly referred to as a work table. So if I'm going to join two or more tables, SQL Server typically has an intermediate result set. So if, let's say I'm going to join table A, B, and C. When I join A against B, typically it uses hopefully it uses indexes that are properly formed to match the your join conditions and or your where clause, and it will join those two tables, but then it has to join it with table C. So in order to do that, it has to take that intermediate result set and put it somewhere, and that goes in TempDB. That's called a work table. That happens almost every time you run a query. And if there's any kind of join, if you need any kind of hashing or anything like that, it's going to use TempDB. Well, TempDB has a couple components of it. It's memory and it's disk, pretty much like the user databases. And by that I mean that you can actually do operations in TempDB and almost not even hit the disk. So if you have enough memory and it's the right type of operation, SQL Server can use memory for the data buffers for TempDB, with one exception. Can anybody tell me what that exception is? What always has to be written to disk? Well, the definition of the structure itself. If you're creating a temporary table or a work table, that definition has to be written to the system tables in TempDB. So you're creating a table, it's pound Fred, and it's got column 1, 2, and 3, and they're this type of data types. That information goes into the system tables in TempDB just like it does for a regular database in the system tables in the user databases. The big difference, though, is that's happening generally lots more times. In a user database, you might create a table, every so often, maybe even just a couple times a day. Not a big deal when you're updating those system tables. But if I've got a stored procedure that creates a temporary table, and then I'm calling that from every login script on this website, and I've got 1,000 concurrent users, I'm creating 1,000 temporary tables all at the same time in TempDB. That information has to be written into those system tables. And that's one of the forms of the contention. That's the DDL contention on there. When I go to write that, it has to update certain aspects of it, not only the structure, but there's 3 system type, they're not tables, they're pages in the data files. There's the GAM, the SGAM, and the PFS page. The GAM is global allocation map. SGAM is shared global allocation map, and then PFS is page free space. When you allocate an extent to a table or an index, it has to use either the GAM or the SGAM to say this extent belongs to this object. Let's forget about the SGAM for a second. But if I'm creating 1,000 temporary tables all at the same time, I need to update that GAM 1,000 different times, but all at the same time. So they take latches to use that, and you're going to eventually get what's called latch contention, because everybody's trying to do it at the same time, and there's only one. Let's see, a GAM. I think there's one per 4 gigabyte of data file on that. So at the time you're creating it, it's probably all going to be within that single file, and you will get the DDL contention that we were talking about before. The page free space page is if you're inserting into a heap, and most temporary tables are heaps, unless you've explicitly defined a clustered index on that temporary table, which none of the work tables are going to have that, right? So they're essentially heaps. Every time you go to insert a row into a heap, SQL Server has to look at the size of the row, and it says, okay, it's 54 bytes long. And then it says, find me a page that has at least 54 bytes of free space on it, and that's where I'm going to put it. In a heap, there's no telling where that's going to go. It can go in this page, it can go in that page, it can go in any page in between. And to find that, again, it uses this PFS thing because it has ratios. It says this page is 10% full, it's 30% full, it's 60% full, et cetera, et cetera. So it looks at that page to say, where's the first one to put that in, and then what does it have to do once it says, okay, that's where I want to put it? It has to update it, because I'm going to put the row on now. If it was 30% or if it was 30% before, now maybe it's 40% full. Well, it has to update it to make that happen. Again, that's happening with every row that you're inserting into those temporary tables on that. So these PFS pages get hit pretty heavily as well. And then you start getting this latch contention, which just means that you're sitting there in a queue waiting for everybody else. If you're in that 1,000 user scenario, you could be the 1,000th 1,000th user, and you could be waiting till the other 999 have gone through their process of waiting and updating, waiting and updating, waiting and updating, etc. So it can be a big deal. Now, there's some things we can do about that, and we'll talk about that in a minute. The DML contention, the data manipulation contention, kind of along the same ways. It's you're modifying some of the data, you're inserting rows. The DDL is really creating the object to begin with and getting that structure, and then the DML is inserting those rows. So those two things together all have a problem where you could have that contention on there. And TempDB is going to be the one where you're going to get hit the most with that, because it is one database for everything that's happening on that. Has anybody seen this contention yet? If you haven't looked in the right place, then you wouldn't know it, or you might not know it, but I'll show you how you can find out what that is. It's actually pretty easy to find. And in some ways, it's easy to fix as well, and again, I'll show you that in a second. So, there's a couple counters you can look at. Don't worry about writing down all of these. I've got a bunch of scripts that I'll pass out with the demos that have pre-written queries that have all this stuff in there. You just have to run the queries on there. But there are some perf on counters that you can look at if you want to get a handle on what's going on in TempDB, just to, again, get a reference. A lot of performance monitoring is just getting to know your system, getting to know how it works at any given time. During the week, when it's just normal activity, you want to know what's going on. How many transactions per second? How busy is TempDB? How much is this happening? On the end of the week, you do reporting at the end of the week or whatever. What's it look like then? What's it look like at night when we do our batch processing? It's just getting to know the system. That's really one of the first steps when it comes to performance monitoring. If you don't know what's going on in your system, then it's kind of hard to tell whether or not it's working right or not. So some issues that you run across. One of the biggest ones is going to be I/O, just like any other database. I/O overall is the #1 bottleneck when it comes to proper operation of SQL Server. We've come a long way with lots of things, especially memory and CPU. I have one of my clients. We've got 8 or 10 DL980s, which are either 64 or 128K. I'm sorry, 64 or 128 core boxes. So I've got 128 cores that we're running on there. And we have, most of these boxes, we have 2 terabytes of memory on these boxes. We've got some big data. We've got one of the servers, we're probably pushing 70 or 80 terabytes worth of data and in a data warehouse situation. So what's our bottleneck? We've got plenty of CPU. We got, well, I would still like to have more memory. Even though I've got 2 terabytes, I'd like to have more memory. Why? Because if I've got 80 terabytes of data and I'm reading a lot of that, 2 terabytes isn't a whole lot. So that brings it back to disk. Disk is almost always going to be your bottleneck. If you're in a situation where your database is relatively small and you can slap it on an SSD or something like that, that's great, but that's not going to be the average. The average is that people are going to have underpowered hardware when it comes to the storage, and that's going to be your biggest bottleneck. Same with TempDB. There are some things that you can do to get around that. If it is going to be on traditional hard disk, try to make sure it's a RAID 10 type of an array. It's going to be the best thing for both reads and writes on the SAN. Problem is, a lot of times you're not going to be able to have that luxury of getting, you're going to get what they give you, but that would be what you would prefer. Spread TempDB across as many spindles as you can. That is, again, no different than any other user database, but if you had to pick one, TempDB is probably the one you want to concentrate on first. There's a white paper. It's a pretty good white paper, as a matter of fact, when it comes to not only just TempDB, but performance troubleshooting in general, but it has a big section on TempDB in there, and it goes over a lot of that stuff. I recommend that you take a look at that.
I'm just curious about the TempDB one across many spindles. Is that something that's easy to do and you just configure it, or is that actually...
Okay, so in spreading TempDB across as many spindles, what I mean by that is in your disk array, if it's going to be a RAID 10 or RAID 5 or whatever it is, the idea of that is just have as many physical disks as you can, and by spindles, let's just say physical disks in that array. And that wouldn't be something that you would do from a TempDB perspective. You would want to make sure that the storage that you're putting TempDB on has lots of disks on there. And the reason for that is because you can only do so many I/O operations per second for a given hard drive. And let's just say with a 10,000 RPM physical hard drive, you might be able to do 100 random I/O operations per second on that. And you know, whatever that number is, that's a limitation of the physical media. The only way to push more I/O through is to have more physical disks. So by saying spreading across as many spindles, that means add as many as you can to the array. Now, of course, that comes with a cost. I mean, a monetary cost, hardware, space, you know, all those kind of things. But if you're limited, if you're limiting yourself by putting TempDB on, say, a 3-disk RAID 5, then you're only going to get so much throughput with that. And if you need to do more than that, then you're stuck. You're limiting yourself because of that throughput on there. One other thing. Another option might be to put it and go from a physical hard drive to a solid-state device of some sort, which doesn't have the same limitations as the physical spinning medium.
That's what I was going to ask. I mean, if you have SSD, do you need more spindles?
If you have SSD, do you need more spindles? No. As long as you have enough SSD to fit the entire thing you're trying to put on there. And again, I'll come back to these big machines that we have. We have 2 terabytes of RAM, but I added in Fusion I/O cards, which are PCI-based SSD. And we took TempDB off the SAN and put them onto the Fusion I/O cards. And we went from, you know, a second plus average latencies down to 1 or 2 millisecond latencies on there. But the problem is that even though with some of the servers anyway, the initial ones, the way we had it configured, we had about 600 gigabytes of usable space on these SSDs. Sounds like a lot, but our TempDB oftentimes will fill up that space on there. So the problem with SSDs is they're expensive, and generally you only have so much of them. So if you don't have enough room to put what you need on there, you might be forced to use the physical media on there. But if you have the luxury of using SSDs for TempDB, that's one of the that's likely one of the best things to use it for. Now, you can't say that just across the board. You have to look at your system. Going back to what I said before, you have to know your system. If you go and buy these, go out and spend $10,000 and put TempDB on these SSDs, you might find that your performance didn't change one bit. If you didn't look first to see, is TempDB a bottleneck, and then you just go do it, then you just wasted the money. And that's why I emphasize, look at the big picture. First, find out where your bottlenecks are. And then if you find out it is disk, figure out which database or databases are the biggest problems, and then moving those to the SSDs will give you the biggest bang for the buck. And when we get to the next section in the slides, the file stats, we'll talk about how to figure out what that is.
Thank you. That was a good answer.
Okay. TempDB Caching. Some of the things that they've done over the years by making changes in both the released versions and the service packs, and in some cases hotfixes or cumulative updates. They have recognized the fact that this contention happens a lot, especially on the bigger systems. Now that we've got systems that will routinely, you know, do 50 or 100,000 transactions per second, we're trying to do that in TempDB. We can't do it if everybody's all fighting for that same thing. So back in 2005, they started to add some capabilities in to address that, and they fine-tuned it over the editions. And I don't know anymore when and where, but I know it started in 2005 and it's gotten better ever since. But one of the things that they did was they cached the temp table definitions. And I mentioned before that when you create a temporary table, that definition, you know, it's table this, it's column this, the data type this, et cetera, it's got to go in the system tables. And if I have a store procedure that creates that temporary table, and then I issue it 1,000 times concurrently, I'm creating 1,000 copies of that. Or, you know, even if it's one after another, it's really the same thing over and over again. Behind the scenes, they all get their own name, so it's a unique copy, but the definition of that table, which is the stuff that has to go into the system tables, is the same. So what they did is had the ability to cache that, and they would, if you create the temporary table the first time, it would keep that definition in cache, so the next time somebody called it, it would pull it out of the cache instead of having to physically do the write and the read on the disk. And they've, like I said, they've improved that. But one of the things that would kill that was explicitly dropping the temp table. So if I said create table pound Fred, did my work, and then said drop table pound Fred, it would pull that out of cache. And then so when the next store procedure got called, it would have to go through the whole process all over again. If I didn't drop it, if I just let the store procedure clean up on its own, which anytime you close the session, you have temporary objects open, it will get cleaned up automatically by itself. Then it would stay in the cache for X period of time until it's not used anymore on there. So just one thing, I had a client who was trying to do store procedures very, very, very fast, and they were having problems, and I saw they were dropping the temp table. I told them to take that out, and that's all they did. They just commented out that line, the drop. And then they went from about 400 executions per second to they were being bottlenecked. Once they commented out that line, they were able to hit about 8,000 per second on that. It was a big deal on there. And somebody had a question.
Yeah, yeah, I'm one of the stupid programmers who drops temp. If object exists, I drop it.
Mm-hmm.
Because I don't know when maybe it got fixed, but in the older days of .NET, the memory pooling sometimes would really hose things up, and you'd run something that said the temp table did exist.
Right.
And it wasn't your temp table.
Yeah, that was years and years ago. They did have some issues with some things, but nowadays that shouldn't.
That leads to the second question. Is again, just because I'm a lazy programmer, it's pound temp, temp 1, temp 2, temp 3. And if different procedures are creating different temp tables under that, is that going to affect the caching? Or should I say, okay, here's my stored procedure, and maybe prefix the temp table with a prefix that's maybe appropriate to that stored procedure, so the table's cached?
Well, okay, so really the question is if you're going to have multiple store procedures, should you name the temp table the same to get the caching? Well,
no. If I'm going to run one stored procedure thousands of times,
right, okay.
and it's using pound temp, and then I have 30 other stored procedures all using pound temp, but they're all different.
The table itself is different, the
Yeah.
definition is different?
Yeah. Just select into temp. I mean, what can I tell you?
There is, that's a good question. So the question is, if they're all named pound temp, but they're physically different in their structure, in their definition, what does that do? And if I remember correctly, they do have some kind of an algorithm that tells them which is, it's not just by the name, there's some other things in there. But I have not really thought about, should you call it something else? I usually call temp tables, I give them a name that's kind of descriptive as what I'm doing with them. So generally I don't call them the same thing all the time. So I guess I never really thought about that. But
Would it be just a question of scoping? It scopes to the local variable to, whatever the pot color is.
well, the scoping with a temp table, with a regular pound temp table, the scoping is the normal scoping is within your session. But as far as the caching goes, it's in the instance. It's in the instance of TempDB, which everybody shares for the caching. But the actual data and access to that stuff is different. So the only thing that's being cached is the definition. And I should try and ask somebody. Connor Cunningham is the developer who did a lot of this stuff at Microsoft, and I'm going to see him in a month or so. And I'll have to try to make a note to ask him how that works. So I hadn't really thought about that, but I think it's covered, so I don't think it is an issue. But the big thing is that I just would not drop. The only time I recommend dropping the temporary tables is if you've got a lot of data in that table and you don't need it anymore. If your store procedure is going to take 10 seconds to run, and at the beginning I populated a table and I've got 1 million rows in there, and I'm done with it, but my store procedure is going to run for another 10 seconds, then I would explicitly drop that. So, because that kind of thing is usually not the thing you're going to run 10,000 times a second. It's not going to be run as often. And if you've got a lot of data, go ahead and drop it so that you can allocate. What happens when you drop the temp table, it not only gets rid of the table definition, but it clears up all the pages that were allocated for the data that was held in that and lets it be reused. Whereas with the caching thing, what it does is it drops, if you let SQL Server do it, it deallocates all the pages that has the data so they can be reused, just keeps the cache definition around on there. So if it's something you use infrequently, and especially if it's got a lot of data, go ahead and explicitly drop it. That's not a problem. But if you're using it over and over and over again, then think twice about it.
Yeah, and the other time you drop it is if you're changing it.
Changing it.
If you have a temp table that's changing on you, maybe you're having different columns in it dynamically, you have to drop it. Otherwise, the procedure will blow up, so it'll come give you a message that the temp table didn't match what it thought it was.
Well, the temp table would be created every time you run the store procedure. So if you change the store,
that way when I'm doing development, it'll blow up on me.
well, if you create a table in a store procedure, and then you call another store procedure, that temporary table is actually still in scope with the other store procedure. So if you change the outer one and didn't change the inner one, then yes, you could have a problem. But if it's all contained within that store procedure and you change it, then it's only there. It doesn't matter whether 10 people are using it or not. It'll account for that on there. But if you're calling nested things, it will be an issue. I think you had a question?
Yeah, I mean, one of these they used to say create the temp tables at the very beginning and all the stuff. And is there any difference where we can just say select star into temp table, or we just create the table the top? Doesn't make any sense.
Okay, so a good question. The question essentially is, and Mark and I were talking about this on email the other day, it's recommended that you create your temporary objects at the beginning of the store procedure. And the reason for that is for recompiling. It's not as bad as it used to be in like 2005. They addressed some of the things. But if I had a store procedure that had 1,000 lines of code, and I go to run it, it gets compiled the first time you run it, not when you create it, when you run it. So the first time I run it, it has to go through all 1,000 lines of code and figure out what the proper plan is for each and every line. If it went through 500 lines and it got to a creation of a temporary table, now the statistics are going to change because that table, when it started doing it, that temp table didn't exist. It didn't know anything about it. When it got to the 500th line, now all of a sudden this table gets created and it says, okay, I've got this new thing, and it has to go and recompile the store, or it used to have to recompile the store procedure. And it would have to go back and start from line 1 again and go all the way down. Nowadays, one of the things that it can alleviate that is that it can pull out that individual line or a couple lines that are affected by that, put it in its own plan, and only that would have been recompiled and all the rest wouldn't. So it's gotten a lot better than that, but the idea was that it wanted to know about it as soon as possible so that if it was going to recompile, you didn't have to redo a bunch of work. But it's not as bad as it sounds, because if I do create a temporary table, the store procedure will get recompiled, and the next time you run it, it won't recompile again when it gets to that because it's already got the new plan. It knows about it now. It's got the new one. If you add rows to it now and you get past the threshold and you change the stats, it'll get recompiled again, but it won't. But it'll be there for the next time. So it's not like it's going to happen each and every time. It used to be really bad. It's not quite as bad anymore.
Andrew, wasn't part of it, from what you have taught me on a few things, is one of the key ingredients was when they rolled a separate plan out for some of these pieces of code inside the store procedure, where you'd have, this is used over here, so you get a separate plan, and it can use that again.
Right.
So that also prevented recompiles because of bizarre if statements and all kinds of things that if you had created a temp table inside of an if statement on a certain condition, this helps resolve some of that.
Well, it could. I mean, this essentially, if you can break out a very large procedure into multiple smaller ones, that's oftentimes that is better because you can, it can be optimized, potentially it can be optimized better because it's a lot less going on in each one. But if you do have a situation where one part has to be recompiled, it doesn't affect the rest of it.
Right.
All right, so I am going to just show a few real quick things on TempDB here. Again, you'll have these scripts, so you guys can play around with them as much as you want. There's just a couple things in here to help you go through that. Like this one here displays the stuff in TempDB. Now, I don't have much going on. As a matter of fact, let me create the table. I'm going to create, using a select into, a couple temporary tables, and then I'm going to create a real table. And if I run this, this procedure, it'll just give me some information, show me the temporary tables, gives me a little bit of information about it, tells me how much space used. It's the kind of thing that I use on a regular basis just to get a feel for what's going on in TempDB. It not only tells me how much space is being used, but it gives me an idea of what's going on in there. You know, are there real tables? Are they temporary tables? Are there big temporary tables, a bunch of small ones? You know, all of that stuff goes into the getting the big picture and getting a handle on what's going on in your system. So if you run this every so often, it'll give you a feel for how TempDB is being used on there. One of the store procedures that I wrote here is, where's it at? Find temp table owners. No, I just pulled the wrong one. I had a situation where there were a lot of real tables being created in TempDB. Real meaning that not pound. Somebody said create table, my table, and it was in TempDB. And they're using up a lot of space. And as I mentioned before, we have a limited amount of space on those SSDs, and they were creating tables that were hundreds of gigabytes in size. So I wanted to find out where it was. Well, if I look in there, if you just go to TempDB and say, show me what's in there, what do you see? I see dbo.real table, okay? Who created that? No clue, and you cannot find it by going through Management Studio. So I wrote a store procedure. Actually, I took a store procedure that Jonathan, I was a butcher's name, Kihines, that he had, and it didn't quite do what I wanted, so I modified it. So I started with his, and I wrote this. And what it does is it will go through and it'll look at the default trace, which is by default is always running on your machine. And every time you create an object, it gets stored or it gets logged in the default trace, including the temporary tables there. So I went and looked in the trace and coordinated the table to the trace, and then I was able to get the SPID and the user name of who created that table in there. And it came in very handy for me, so I put it in there because if it came in handy for me, chances are it would come in handy for somebody else.
DB?
What's that?
Is the DB who did that?
No, we have users who know nothing about SQL Server, and literally know nothing about SQL Server, yet they've been tasked to write these research projects. And one last thing that I want to put in here is TempDB space usage. There's a whole bunch of different queries in here, and it'll give you different things, like just space usage, gives you how much is there, but it breaks it down by not just the space used, it breaks it down by the type of things that are in there. For instance, a version store. If you're using any of the snapshot isolation levels, you're going to use the version store. The version store is also used by several internal SQL Server things, like if you run a CheckDB, or there's a number of different things that will use that. And the space used by that will show up there. And then you have user objects, space used, and you have internal objects, space used. So if I have a person who created a temporary table, explicitly pound Fred, it'll show up in the user object, If it's a work table, like the results of a join or a hash merge or something like that, it'll show up as internal object space. So again, gives me a feel for how TempDB is being utilized. If I see a lot of space in the version store, then I can go and look at this query here, which won't show me anything right now because it's not being used, but that tells me how much space is being used, and this one will tell me or show me the transactions and show me who's got that transaction open that's causing all that version store space to be utilized in there. The next couple ones will look at the TempDB itself. This one shows a historical view, and I'll explain that in a minute. Well, I don't have much going on in here, but the reason I say historical view is because SQL Server is not very good about updating all the counters in TempDB as far as the space used. If you're in the process of using it, some of these dynamic management views will not show that space is being allocated. I could have 100 gigabytes being used, but some of the DMVs don't show that until they're done with it. Or, if they're doing a select star into a temporary table and it's going to end up being 100 gigabytes, until it's done doing the select star, that data is not being updated. So some of these queries show you the historical, it'll show you what they were used, and it shows allocated and deallocated space for each one because it's historical. So if they allocated 100 gigabytes and then they dropped the table, they deallocated 100 gigabytes. As long as their connection is still there, it keeps that history, and again, gives you an insight into who's using TempDB, who's using it the most on that, who's keeping it open, maybe they used a lot of TempDB, but they don't keep it around for a long time, but then you get this other guy who keeps it around for 3 days at a time. These are the kind of things that you need to keep an eye on. And we'll come back to TempDB in just a few minutes, and when we look at the SP who is active, we'll take a look at the DDL and the DML contention kind of stuff with that. Okay, so there's a lot of things in here. I recommend you go in and play with it and run these queries in your production server. They're just queries. There's no, you're not going to burn your system down. If you do, don't. I didn't tell you to do that. But no, they're just queries. They're pretty harmless. You're not going to want to run them put them in a loop and run them every second, but get an idea of what's going on in your system. You'll be surprised at what you find in there, and you'll gain a lot of insight into what's going on as well. All right. So next couple I'm going to go through kind of fast. Each of these are one of those things where I have a whole session on there, but this is just to get the view of that file stats. Anybody use the DMV, DM virtual file stats? Everybody should be looking at that. Every time, let me just put this up here. Every time you physically read or write to a physical disk, SQL Server keeps track of that. It keeps track of how many times you wrote, how many times you read, how many bytes that you wrote or read, and then how long it took for that to happen. And they call it I/O stall. It's how many milliseconds that took to occur. And there's a few other things in there as well. But that's physical access. And physical access is what I mentioned before, is going to be your number one bottleneck in most cases. If it's in memory and you're reading out of the cache, then you don't have, these counters are not being added to, as long as it doesn't have to physically go to the disk to bring it into memory or write it from memory to disk. But it's the physical aspect of it. And there are two stored procedures that, by the way, I have a blog. I blog on SQLblog.com. Well, I'll get back to you in a second. And I don't blog that often these days, but I just put up onto that blog updated versions of my file and wait stats things. But the ones that are in here are the same ones that are on that website. So if you see that, you're questioning that. You had a question?
Yeah. I was trying to the slow I/O issue where I stored all the IO stats data. So can I correlate with the IO stalls and the performance data?
Can you correlate it with that?
So IO stalls and the latency, do they go hand in hand with each other, or both are
Well,
completely different?
The IO stalls that you see from virtual file stats and the latency that you get through Perpmon, they will correlate to a degree. But they have different stacks that they take. But if you have slow times, you're going to see slow latency with Perpmon, and you're going to see slow latency through the file stats as well. But if you see it in here, it is something that you can count on. If it says that you read this much, and it's taking a lot of time, then you can believe it. It's not lying to you. It's actual numbers in there that you can count on and see. And this right here, I just made a cursor. I went through AdventureWorks, and I'm basically reading every table in the database, and I'm flushing out the buffers with DBCC drop clean buffers, which says flush out the buffer cache every time I read. Why am I doing that? I want physical I/O, not logical I/O. So I don't want to read the data from the cache. I want to make sure it comes from disk first into the cache. And that'll take a while to run if I let it go. Before I started it, I ran this stored procedure. It's called gather file stats. It says 2012, but this will work back to 2005. Same with my weight stat one on there. The only real difference in the weight stats, I filter out more things as each edition goes, but it's backwards compatible on there. So I used to keep all of them around, and then I realized the other day when I was redoing this, I don't need those other ones. If you got this one, it'll work back. It doesn't work on 2000, but if you're on 2000, you're on your own. So what the gather one does, it does very simple. It will create a table in whatever database you happen to be in. I'm using TempDB. I don't normally wouldn't recommend TempDB unless it's just a temporary thing. I would normally have a database set aside that I would keep my maintenance type things in. And then I would have a SQL agent job that would capture this every 4 hours, 6 hours, 8 hours, whatever you want to. But if the table doesn't exist, it creates it, and then it does an insert into select from the virtual file stats with null, meaning give me every database and every data file, or every file, data and log. So for every database, every file, give me the virtual stats on that, and it puts it into that table. Gives it a capture time. And it's the same for the entire batch. So if I have 100 rows because I have 10 databases with 10 files, they all have that same capture time. And then I ran that other thing here that generates the I/O, and now I'm going to run another capture. So it puts a second snapshot in. One snapshot is never good because you don't really have anything to relate it to. You need a defined time period, and hopefully you know what was happening during that time period so you can correlate it to the real life. But you're always taking a delta. You can specify, and if you go to my blog, I've outlined it in there, but I've added some options. You can specify a begin time and an end time. They're all optional. But if you don't put anything, it'll take the first and the very last snapshot and do the delta report on it. You can limit it by top end. In the case of file stats, it will order by milliseconds. By default, it will order by the I/O stall total in milliseconds descending. So it'll give me my worst performing files. And then in the case of file stats, I can specify a database ID as well. So if I wanted to look at just TempDB, I could run this, and I could put in like this one here, I could put, actually that's for weight stats. Here's one here where it's got database 2. These snapshot times are not going to correlate, but if I ran it, it's only giving me TempDB, DB ID 2. But let's just run the report just with the defaults, and it's going to give me the start and the end time of the 2 snapshots and what the duration was in hours, minutes, seconds, or days, depending on how long it was. And then it will, by default, it'll spit out for every database, every file for every database, and it tells me all that information that I want to know. For instance, I can see on here that I was reading quite a bit from this, or actually this one here. I was reading quite a bit from this, and I had a total I/O stalls of 25,000 milliseconds, but my average stall was 9 milliseconds. Okay. Again, I have SSDs in here, and it doesn't really mean a whole lot. But if you run this in your production system, you will get a feel for what's working fine and what's not working fine. And what's working fine, the definition of fine, that's going to depend somewhat on your environment and what your users are willing to tolerate there. But if you're seeing the I/O take 15 seconds or longer, that's not fine. I don't care what the users say. That's not fine. So that's the file stats. It's that simple. You got that stored procedure to capture it, dumps it into a table, and then the reporting one does the deltas. You know, again, set up a job, capture it every 4 or 6 hours, and then periodically run the report and say, what's, you know, how's my system looking during the day or at night or when I do the batch loads or, you know, whatever the case may be on that. It's very, very easy to do, and it gives you a lot of useful information. So we were talking before about if we got SSDs, you know, your boss won the lottery and he came in and says, I'm going to give you $10,000. You go buy some SSDs. Okay, great. What do you do with them? What do you put on the SSDs? Look at the file stat information. What is giving you the most trouble? Or what do you think would give you the biggest bang for the buck based on, you know, your read and write activity? Any questions on the file stats? All right. So now we get to the weight stats. Weight stats have been around for quite a while. Since 2005 they started out, and they had 194 different weight types. In 2008 they went up to 485 because, for one thing, some of them used to be hidden, and they exposed them, and then they added more. And then in 2012, as of, I think this is our SP1, there's 651 different weight types that are in there. How many people know what all 651 weight types?
Do you?
Yeah, I can list them out here and show you.
I've never documented this. I mean, this is a lot of information, very hard to go and dig. You know, nobody has documented.
Good question. Is there documentation on this? Yes and no. There is a document that was written back for 2005 that I think I actually have a link to in here. It might actually be on the files that you get. It was written by Tom Davidson, who was one of the SQL Cat team members at the time, and it was the best source we had on weight types at the time. Well, it's probably still one of the best things, but it's missing so much. These are some of the most poorly documented parts of SQL Server that are out there, especially the newer ones in 2012, 2008, what they call the preemptive weight types. They're just virtually nothing on them out there. The good news is that they're not a big factor in most cases, so most of the time it doesn't matter whether you know what they are or not because they're not going to be a factor. But there are other ones that everybody will see, and there's documentation if you look around, but it's not very, very well defined on there. I'm going to talk about a couple of them here in a second. But what happens with weight stats is that every time SQL Server goes to do something, if it can't do it right away, it will go into a wait state. And I'll use the example I use all the time is I'm going to select from a table, select star from customers. In order to read the data, the data has to be in the data cache. It has to be inside SQL Server's data buffer cache. It does not read directly from disk. So the engine will say, go and read me these pages. If they're not in the cache, it sends a request out behind the scenes to get that data from disk and put it in the cache, and then it can read it. It's a separate operation. So if I'm going to read this table, and I start say there is some of the data in the cache, and I start reading, and all of a sudden I get to a point where I run out of data, I have to go to disk. Well, it's going to take a while for that to happen. So SQL Server, that thread that was operating on that thread, it can't stay on the CPU because it would just sit there doing nothing, and it would block everybody else from doing something. I might have 1,000 people all trying to do something at the same time, and the way SQL Server does that is the threads get swapped on and off the cores as they have work to be done. Well, once I get to that point where I can no longer do anything, and actually we'll look at this next page here, If I started the query here, or started the query and then I got to the point where the data was not in the cache, SQL Server had to wait. So this T0, this red line, was when it started waiting, and that was a resource wait, meaning in this case I was waiting on disk. So it had to wait for the data to come from physical disk and be put into memory. So at that point, that thread gets pulled off of the processor and gets stuck in a queue, and somebody else who was running, or who was waiting to run, who can run, but needed a spot on the processor, gets stuck on there. And as time goes on, there's this thread in the background that's going and getting that data. Once it's in the cache and it's ready to be read, it sends a signal and says, hey, you're good to go now. But that thread probably can't start reading that right at that very moment because somebody else is on the processor doing their work. You're now in a queue behind them. And that's this T1, or this blue line here. That's the point when the resource was available, but it's not necessarily the time you can start using it. You wait until your turn back onto the processor, and at that point, that's the green line, or T2. That's when you actually get put back on and can actually finish reading that data. So the overall time is the overall wait time, but it's broken down into a resource wait time and a signal wait time. The resource is the time you waited on the actual resource, what it was that put you in that wait state to begin with. And when it put you in that wait state, it categorized you. It gave you, assigned you to a wait type. One of those, 485 or 651 different wait types, it assigned you to one of those. And then it started keeping track and said, okay, we're waiting, 10 milliseconds, 20 milliseconds, whatever the case may be. And then once it finally gets on there and starts running, it stops the waits, and it's actually doing its thing. Now, it may wait again down the road for something else, or if it needs more data, but at that particular time, that wait is ended. Now, there's a difference between the resource wait and the signal wait. If this were true, proportionally, if this were true, I would say just a little more than half the time I waited on the resource. So a little less than half time I waited on what? CPU, right. If this was the other way around, if this blue line was over here and say 10% of the time I waited on disk and the other 90% was signal waits or CPU waits, if I just looked at the wait type, the wait type's telling me I'm waiting on what? Disk. Right. So if I just look at the wait types and I say, okay, I'm waiting all this time on disk, I go out and I spend $100,000 and buy all this new disk, and in reality, I was waiting on CPU 90% of the time and disk only 10% of the time. I go spend that $100,000 and now it didn't solve me one bit because I was CPU bound. I was not disk bound. Now, that's not generally the case these days. Generally, we have extra CPU, not enough disk, but that doesn't mean that's the case. The systems that I was working on, we just made some major changes, and we were big-time disk bottlenecked. And I was able to get some processes off. I was able to move TempDB. These are different machines, but move them to Fusion I/O cards. And all of a sudden, I went from being disk bottlenecked to CPU bottlenecked, just like that. And so my wait types were no longer disk waits. I mean, if they show up disk, but most of my wait was signal wait, which meant I was waiting on the processors. If I didn't break it down, I wouldn't know that. And if you just look at the overall wait statistics, you're going to see the wait type of disk. You need to break it down and see the whole picture. Well, let's go ahead and take a look at that. Like I said, I know some of you have heard that before. You've seen me give that speech before. And the gather wait stats is the same principle as the file stats. It just puts it into a table. The report's a little more complex. I'll talk about that in a second. So now I'm going to gather. I'm going to initialize a wait stat, and then I'm going to kick off. I don't even know. It doesn't do much. It just does some activity. It doesn't matter a whole lot. Excuse me, what it's doing in there. As a matter of fact, I'm just going to go ahead and kill it. Well, let's go ahead and take another snapshot, and then let's look at the report. Just like before, it gives me the start and end time and the duration. It's 17 seconds. It'll be longer than that typically when you're looking at it, but it will order the results. It'll give you a total at the top by resource weights, and if I expand this out, we can see that's requests, and it will give me the list in decreasing order by total wait time in milliseconds on there. So to give me the 100%, and then it will show me what I'm waiting on the most on there. Now, we'll go over what in real life, what you see more often than not. Don't worry about what this order is because it's not a very indicative test. But it does show you how many times it waited. That's the request. That's how many times it actually had to want to do something and couldn't do it, and it waited for that. The total wait time is just that, the total. It's the resource wait and the signal wait. It's the total. The max time, I have it there only because just for FYI, but the total wait time is, the max wait time does not get reset in between the individual batches. It's a one, it just keeps track of I'm sorry, not the total, the max. It just keeps track of whatever the max was. That could have happened 3 days ago, or it could have happened 10 minutes ago. I don't know that in what I'm doing. So I just put it there as a reference, but for the most part, you can forget about the max. It tells me, breaks it down by percentage of total, and then it breaks it down by resource and signal weights, both by milliseconds and by percentage. Here's signal, and then it gives the average on the far side. So you can, at a glance, you can take a look at this, and you can see what is the ratio of my resource weights to my signal weights. If you get a situation where, like this one here, 99% of the signal weights, well, that's that. Again, this is not a great sample. I didn't have a meaningful thing running in there, but you can look at how much it's weighting on the resource and how much weighting on the signal, and you can determine right away it's either CPU or it's not. And now you can go down the right path and you can troubleshoot the right aspect. It doesn't tell you what's wrong, but if it says you're waiting on disk, you know you're waiting on disk. Then you got to go find out, okay, why am I waiting on disk? But at least you know that is what you're waiting on the most on there. It's that straightforward. The report does it for you. It outlines it all there, and now you just got to look at it and decide what you would go from there. We'll take a couple minutes. I've got what are the most common ways, because again, we can see some things on here, but a lot of these wouldn't even show up at the top just because there's nothing going on my machine. In your normal production, a lot of these would be so far down you wouldn't even see it. As a matter of fact, in my new procs, I have the thing where you can put a top 10, and it'll only show you the top 10. Now, that snapshot is wrong. The date and times are wrong, so that's why there's nothing showing up in there. But I could do that with. Oh, what did I do?
Did you want that on the report, Brian?
Oh, yeah. See what I mean? Well, anyway, you get the idea. Just because of limited time, I'm going on there. But the report is very simple to run, and I actually, for both the file and the wait stats, I have a spreadsheet that you can copy the results right out of the grid without the headers and plop it into the spreadsheet, and it does formatting for you, puts in the comments and all that other kind of stuff in there. So you can keep track of it, and I got different pages so you can take a snapshot, in the morning, one in the afternoon, et cetera, and you can compare them on there. So what you're looking for is, okay, well, what am I waiting on the most? What should I be spending my time on? And if we were to take that spreadsheet and then turn it into a pie chart, it would look something like this. Well, by looking at that, what would you say would be the thing that you would probably want to look at first?
Crummy SQL.
Yeah, Chrome you see, well, but I just mean like out of this whole thing, this is the breakdown on that, it's a pie chart, so what has the most? Well, this one is our biggest contender. It's CX packet weight, which may or may not be a problem, and I'll talk about that in a second. But it does tell you that's what I'm waiting on the most. And then page latch IO latch shared, which is physical disk, and then so on and so forth down the line. I mean, it's going to look something like that. And those weights, the most common weights that you'll see, and not necessarily in the order of what you'll see them, but just some of the most common ones you'll see. One of them is CX packet weight. It probably will be the highest on your list, especially if you've not adjusted your max DOP setting from the default of 0. CX packet weights are a direct result of parallel processing. If you have parallel operations happening, you will have CX packet weights. Even if you're not really waiting on any other resources, which I'll come back to in a second, you will have CX packet weights. But and that's when they're good. Problem is a lot of parallel operations aren't good parallel operations on there, especially when you have systems like bad I/O, slow disk subsystems. SQL Server, when it goes to run the query, will look at all the aspects of it and says, okay, this is one honking query, and I've got 32 processors and my max DOP set to 0, which means it can use all 32 if it wants to under the right conditions. So it says, okay, I'm going to process this query and I'm going to use 16 threads to go do it. Actually, let's say 13 threads on that. Usually there's an even number of threads that it'll put to a core. So it might say I want to use 4 cores or 4 schedulers. So it'll assign 4 threads to each of those. So that'll be, well, in this case it'll be 16. And then there'll be a 17th one, which is a manager thread, which kind of looks over the top of them on there. So a lot of times you'll see there it's an odd number on that. Problem is, that sounds great. I've got all these threads. I'm going to go off and process this data or process this query. Problem is my disks are connected via a tight string between 2 tin cans. And so the data is crawling over. So what am I going to be waiting on? I'm going to be waiting on disk. Probably that page IO latch shared is going to be very, very high. But since I've spawned, but SQL Server didn't know that. At the time it went to run it, it didn't know that my disk subsystem was slow. All it knew was this was a very expensive query, and I've got lots of processors available. I'm going to go and try and do all of this. So it spawned a whole bunch of threads to work in parallel, and they're each reading their own section of data from this table. But at some point, that data has to be merged back together again. It has to do an operation where the data comes back together. And you're going to get to a point where one of the threads is finished doing its part, and the other threads are still trying to get the data from disk. At that point, that thread cannot go any further until it gets the rest of the data and it starts to merge them and move on. So it sits there and waits. It shows up as a CX packet weight. Just the fact that you're doing a parallel operation shows up as a CX packet weight as well, and that's what can be confusing, because it can be a good and a bad thing. And I'll show you how you can tell the difference in a little bit. But anytime it's waiting on some other resource, like disk, the one or more threads will be sitting there and can do nothing until they have. So what good was spawning all those threads in parallel if you're bottlenecked on your disk and you can only do essentially 1 or 2 threads worth of data at a time, and you've now spawned 16 threads to do all that. That's when you're going to get poor CX packet weight kind of things. So the key is to find out, am I waiting on some other resource? Usually it's going to be disk, or not. And again, I'll show you that in a minute.
So you have everything sliced up. You have a query that's being sliced up across multiple CPUs and cores, and something goes to CX packet. You see it. Now, that means it's done, and it's waiting on something else to finish, correct? When it's waiting there, does it release itself from the resource of that CPU so that CPU core can be used for something else?
Okay, yeah, so that's a good question. So when that thread that was doing its work, all of a sudden it says, hey, I can't do any more because I'm waiting on the other guys. Yes, it goes into a wait state called CX packet wait. It gets pulled off the core and goes into the queue, and somebody else goes on, that some other guy run a query that can work. So that when that data does become available, it's got to get put back on again on there, just like any other wait And so this is going to be a common weight, and you can address it by reducing the amount of parallelism. If your disk can't handle it, then don't try to, the more you throw at it, if it can only do X amount and you're trying to do X plus, all that plus is just a wasted effort. So don't try to do as much. So you can reduce the max DOP or increase your cost threshold for parallelism other than the default of 5. Bring it up to like 40. To say 40 might be a good place to start. And that'll knock out a lot of the more trivial ones, so you're not getting as much parallel stuff and gives a little bit more headroom for the ones that the real heavy hitters.
The 5 was seconds, not milliseconds, right?
It's that time,
The counter.
the cost threshold for parallelism, I think, is a cost setting. I don't think it's a second setting. I think it's just a relative cost.
Okay.
So there's no real meaning to it per se. When I say 40, you can't correlate that to seconds. I mean, even if it said seconds, it's not real seconds.
Okay.
All right, and moving on, another one is going to be locking. How many people encounter blocking? Okay, everybody does. It's just blocking is a normal part of everyday SQL Server. If it becomes excessive, then it becomes a problem. How do you know if it's excessive? Look at your weight stats. If you're spending a significant amount of time in one of these type of weights, that means you're spending a lot of time being blocked on there. If you're one of these, you're being blocked by somebody else. Okay, you'll know that by looking at the weight stats. Async network I/O. Everybody will see this, and it does not mean what you think it means most of the time. It does not mean your network is slow. It used to, but these days networks are almost never the real bottleneck. The networks are, 1 gig, 10 gig, whatever. They're not as slow as they used to be. What it means 99 times out of 100 is your client is slow. Whoever it is that requested that data in the first place, let's say it's a web service, a web app, a desktop, it doesn't matter. Whoever said, ran that select, well, SQL Server gets the query, processes it, and says, okay, I got 10,000 rows, and I'm shoving them back to you. But the client is so slow, either because it's poorly written or it doesn't have enough resources on the box. A lot of times it's a web service, and you've got 1,000 people hitting that same box, and they're trying to share all that CPU and memory. So it's slow to process that. And it's trying to pull back that data, but it'll pull back a row. There's a delay, pull back another row. There's a delay, pull back another row. It's going to show up as async network I/O. 99 times out of 100, it's going to be your client, your middle tier, if you have one, that is overloaded or just written poorly. It's not the network the majority of the time. But it will be one of your higher weights. Almost always will be one of your higher weights. Disk or I/O type of weights, page I/O latch, if it says I/O, it's physical disk type activity. I/O completion, write log, they're all trying to read or write to disk on there. Page latch, without the I/O, is a latching scenario. That's what we talked about before when you can have situations with the DDL or the DML contention like in TempDB. That's latching. It's a lightweight lock on pages that are other than the buffer pool pages. So typically metadata, log pages, things like that on there. Page splits, if you get a lot of page splits, SQL Server takes a latch on the page so it can split and move half the pages off or half the rows off the page. And so that's all done with latching, and you can see a lot of that with this. And some links that will show you some of the things we talked about. This is that white paper, the only definitive white paper that was written specifically for weight stats, but it's for 2005. A lot of it still applies, but it does not have the new weight types in it. And then there's Joe Sack wrote a better thing in 2009, and this one says 2005, but again, it applies to, it's applicable to even today on those things. All right, now the last thing, I know we're right at the end there, but this is an important thing. SP who is active. This is written by Adam Mechanic. He's a fellow MVP. He's from the Boston area. I used to live in New Hampshire, so I knew Adam before he became an MVP. And Adam's a very bright guy, and he gets he does all kinds of things, but he started writing a store procedure to do troubleshooting in his daily life, and he just kept adding to it and adding to it, and he came up with this SP who is active. This thing will do everything but change your sheets on there. It will track, you name it, it will track it. He has a blog, but there's a link at the bottom. It's SQLblog.com. He has 30 or 31 posts. It's a blog a day for a month. He broke it down, and he would do blocking on one day, and he would do, I don't know, deadlocks another day, parallel weights on another day, filtering of this type on this day. So if you want to know how to use this, his blog is probably the best documentation for that. But it's really simple to use in general. If you have, let's see, TempDB, that's what I wanted. I've got a, I'm looking in the wrong place there. This is a tool that Adam wrote as well. I can't give you this tool. You can get it for free. You have to go to Adam, download it from Adam's site. I can't give you this for free. But I have I had a little thing in here. I'm just going to run a select star into pound temp. I'm going to create a temporary table by saying select star into the table from the AdventureWorks sales order header table. And then I'm going to run 100 iterations with 10 different clients. This is going to spawn 10 clients all doing a loop, executing this 100 times. So it would be indicative of a busy system when somebody's trying to run the same store procedure and they're creating a temporary table many times on that. And then we're going to take a look at how that affects TempDB. Now let me get the rest of that set up. I'm just going to get rid of all the other windows so that we don't. Okay. So I'm just going to get a new window and let's say SP. Well, actually, hold on. Okay. By default, if you just run SP who is active with no parameters, it will give you back some basic information, such as anything that is by default, it will show you one or more rows. If anybody is actively doing something, like they're in the middle of running a query or creating a table, altering a table, whatever the case may be, or if they have an active transaction open. So if they run a query, they began a transaction, ran a query, and then they went off to lunch, they're not doing anything, this will show you that it will come up in there because they have an open active transaction at the time. So either of those two conditions will bring up a row. Right now, I've got nothing going on in the system. But it will show you, by default, some good information, how long that process was running, the session, the text that it was running, and by default, that's the line of code that is executing. If I have a store procedure with 50 lines, this will show, by default, the line in that 50 lines that is actively running at the time. Okay, so it'll show you the statement that's running. Login information, and then it'll show you some information like TempDB usage, reads, writes, memory usage, all those kind of good things, the database that it's in, the host name, all the typical kind of stuff you would expect to see in a store proc like that. So just by default, it gives you, it'll suit your needs probably 95% of the time. Now, you might find that, okay, I'm running and it shows me that one statement, but I want to know that one statement out of what. So if you run it with the next one, it says get outer command 1. By the way, his parameters are not the most user-friendly. But if you use that parameter, it will show you the statement and the batch or store procedure that it came from. So it'll say my store procedure and line 52 in there, or there was a batch of those in there. So it gives you the best of both worlds. A little bit more overhead in doing that, but it will give you both on there.
If it's not a store procedure, will you still get the T-SQL?
Yes, if it's a batch, then you had 50
Prepared
lines in the
state.
batch, it'll show you all 50 lines in there. And again, we'll see some of that in a second. The delta interval is kind of nice. You can set that to seconds, and what it'll do is it'll take a snapshot, wait that many seconds, take another snapshot, and then it tells you the difference for all those counters, like the difference during that 5 seconds of how many reads, how many writes, the TempDB usage. It tells you the actual, it tells you the total, and it tells you the delta in there. Very, very cool kind of thing on there. And one other thing is get task info. We're going to see that in a second. It will break down a parallel operation into the different tasks. So normally, by default, it'll just show you one line for that SPID. And if it was a parallel operation and there was 10 lines, you wouldn't see the individual information for each task. It would kind of all be categorized into one. But if you say get task info, it will break it down. So if it's waiting on different things, it'll show you which threads are waiting on which kind of weights. And again, I'll show you that in a second here. The parameters, here's the parameters. If you type the store procedure and you say /help equals 1, it gives you help. It's not necessarily the best help, but it gets you through. The blog that I mentioned, if you want to know more about any particular parameter, go to that blog, and it gives you much, much more detail about that. So let's go ahead and, by default, well, I'm going to run this one here by default, and I'm going to kick in the unit here that's spawning all these threads, and now I'm going to run this. So I see that I've got 3, in this case I have 3, let me run it again, I'll get more. Here's 6 of those 10 clients that we're running. It tells me the statement that they were running, and it's in the form of XML. If you click on it, it'll open up and it'll show you the statement, or the batch, it shows you the whole batch. In this case, there are just 2 lines in the batch, but it does show you the batch. And again, it shows you information in here, like what are they waiting on. In this case, it wasn't waiting on anything at that point. It tells you some other information if they're being blocked. In this case, it does say it's being blocked. One of them is blocking the other ones on there. And that's interesting that it was blocking. I don't think it should on that. But let me run it again and run this one, which is the task info. All right, and that's what I wanted to show you. Let me bring it up to the top. So I said, give me the task info, and it gave me the information before. It says, here's the statement, select star into the table, told me the session number, how long they've been waiting, etc. But this is the part that I was really interested in. It tells me I'm waiting 2 milliseconds on a page latch up. Page latch up is an indication that I've got that DML contention that I talked about before. That's an update latch on the page that typically says that I don't have enough files in my TempDB. And I can further verify it because it tells me TempDB:1 PFS. That's telling me I have contention on the PFS page in TempDB. Right now I only have 1 TempDB file. If I was to create 8 equally sized TempDB files, data files, and I was to run this, those would probably go away. And the reason for that is because now I spread that load across 8 files because each one has its own PFS page. So I've now cut down that load by 8 just by adding those files. And people ask, how many TempDB files should I have? Well, it depends on what your load is like. And the idea is that you add files until you no longer get those page latch ups on there, and then you know that you've had enough. You look at the documentation, some of them will say 1 per processor, but if you've got 64 cores, I can tell you you probably don't need 64 files. I recommend starting on a medium-sized system at 8 files for TempDB. They're going to be equally sized right from the beginning, but if you have 8 files, more than likely you will not see this contention in here. Now the other one and then we'll be done, is CP, oh, no.
Your iterations just one.
Yeah, but it was 40 thread. That shouldn't have gone that fast.
Oh, you also have 40 exceptions.
Oh, that's the thing. What's the exception?
Does dbo.mytable exist in TempDB?
Yeah, actually, that might be it. This is the there's one that I modified some of these to cut it down. I wonder if I left the query out that I was looking to do. What I was looking for was a parallel one, but anyway, I'll go back and I'll show you what it would have done. And if we had a parallel query running, and we set the task info to 1, we would see here multiple sections. So you would have, let's say if we had 13 threads, you might have 2 threads that are waiting on CX packet. And that's what's going to typically show up if you just look at an overall thing, the CX packet, is what you're going to see. But you would show 2 of them and a certain amount waiting on CX packet, but then the other threads will probably be waiting on page IO share. So that tells you that those other threads are waiting on disk. So the first threads are actually waiting on the other threads, which are waiting on disk. And the only way to see that is to break it down by the task info so that you get the individual information from those threads. So if you run the SP who is active with the optional parameter get task info, it will break that down and you'll be able to see those parallel operations and see what kind of things that you're waiting on. If you're waiting on CPU with it, it'll show the CPU waits, but more likely it's going to be disk waits. So the more parallel an operation is, the more likely you're going to be disk bottlenecked because it's more that's going to happen. Not necessarily, but if all you see is 6 CX packet waits, then you're really not waiting on much. You're waiting on the exchange. CX packet is an exchange operator, and you're waiting on the exchange of the information from the other threads. But that's a process that has to happen regardless anyway. It's when you wait on other things like disk that make it an issue on there. So if all you see is CX packets, good to go. But if you see CX packets for some of them and page IO shared for the others, you got disk bottlenecks. Try to reduce the amount of threads you're sending at it because they're just waiting on the disk. So they're not doing anything other than taking up more space on the CPU, more memory, et cetera on that. So you might find things actually run faster by reducing your parallel threads in that case. All right, we went a little bit over, and but we did get through everything. And the last thing here, I think if you have, if you start with SP who is active, and you work your way up from there, I think you're in the best shape. Like I said, it's a learning curve. You got to figure out what you got to go after. You can just run SP who is active on your desktop. I have the window open 24 hours a day on these servers, and when I'm there, I'm constantly looking at that because it is going to tell me what's running, how long they've been running, and what they're doing. Are they using a lot of resources? Are they blocking? Are they being blocked? Are they using a lot of TempDB? Whatever the case may be, it's going to spit it out right in front of me, and then I can then go down from there and try and figure out where to go. But if you do nothing else other than just run SP who is active, you'd be, I think, light years ahead of where you were if you weren't running it. All right. So we don't really have time for questions, I guess, but we did get through the material.
We could do a few questions on it. Because you're a captive audience in Texas that wants to say hi since they provided pizza and hosting. Okay. So anyone have any questions?
How effective is the use of Nova with Nova?
How effective is the use of with no lock? Well, no lock has its place in that it doesn't take out any locks when you're reading data, but it can be a little dangerous. It's very effective in that it can reduce the amount of overhead. If you're reading data and it's static data, then by all means use no lock. But if it's changing data, you may be reading an old version, or you may get an error because some data can move around and you have no control of that. So if it's relatively static data, or you don't care if the data changes in the midst of your query, then no lock can reduce the overhead and speed up your query, and also speed up other people, because you're not going to be blocking other people. But if you need the integrity, then you have to be careful about using no lock. That's always the...
Do you also recommend the read committed snapshot on?
Do I recommend using read committed snapshot on? Yes, if you need it. If you don't need it, no. We can talk more about that in just a second.
Well, thank you, Andrew. Carolyn? Before we wrap up tonight, I just wanted to let Tech Systems speak. Zach and Shamika.
Thanks for coming in. Like I said, I'm Zach with Shamika. We're recruiters here. We work within the applications. Both of our contact information, we have cards up front, so if any of you are interested in hearing more about the market or learning about new opportunities, definitely grab one of our cards and give us a call anytime you feel like it. All right.